All right. Well, I want to do three things today. Um, you may notice, and I have to get this off my chest as we get started here today. We got 28 people. We're missing. Somebody did decline. I guess the 29th. Somebody's in now. Okay, good. So that means there's one person missing. Somebody may be ill or something. I did get an email declining the invitation, so I think that's what we've got. Anyway, I want to get this off my chest. The mathematics, or maybe even the science, if you see it that way, of, and I'm going to mute somebody here. Yep. Of trigonometry, it's fundamental to physics. You really can't do physics without trigonometry. And when I was a student in high school, we actually took a course entitled trigonometry. That name has fallen out of favor in the high school teaching areas. It's been replaced by, I think, something called advanced algebra, but it is the same thing. And Friday of the first week of class, we did spend a lesson with sines, cosines, tangents, and Pythagoras' theorem, the four big rules of trigonometry. And we're going to go on again and do that today. We're going to work more with some trigonometry in order to work with vectors, which are absolutely essential to understanding physics. And the thing I want to make sure we're clear on is how important this is. Okay, it's now the second time we've talked about just trigonometry, math, essentially. And without it, I've had students tell me on exams and other homeworks, things like that, hey, I don't even understand what that question is asking. And I'll try to be very helpful as much as I can in the situation, more so with homework, obviously. But my what's going on in the back of my mind, I'll let you get a little glimpse of that. I'm going, yeah, and probably with your trigonometry, algebra skills, and in some cases in a different class, calculus skills, I can understand why that problem doesn't make sense to you because you can't picture it, okay? In many disciplines, you have to have prerequisite knowledge in order to succeed in the class. And often it's more about the prerequisite skills and knowledge that you bring into the class than what you actually learn in the class. If you can't write well, and throughout your educational background, somebody hasn't taught you to write well or made you be grammatically correct, write paragraphs that are coherent, you're going to struggle in English classes and history classes and other humanities type classes. And of course, in a science class, in a calculational science class, if your mathematics skills aren't where they need to be, well, you're going to struggle. And I recognize out of the 28, 29 people in this class, 28 today, there's a great mix, great spread in abilities. Some of you, I'm sure I am boring to death by talking about trigonometry for a second day. And for you all, I apologize. And you'll see the way I've structured the worksheet today. You don't have to do as much work. For others, if trigonometry isn't something you're good at, I would recommend on today's worksheet that you do more of the problems than the minimum. And that's a personal decision. And at this point, I'm starting to learn your skills by grading your work. But at the end of the day today, we're only 2 weeks into the course. You have to make a decision on, do I just need to do the minimum here? Or in order to succeed in later parts of the course, do I need to do more? Okay. And so, for example, there are going to be 6 problems. The minimum is do 2 of them, okay? But if you're weak in trigonometry, my recommendation is do all 6. I'll look at them. You're only going to get credit for 2, but everything we're going to do from now on until we start talking about energy a few weeks before Thanksgiving, we'll deal with vectors. And the enabler to get those problems right is the understanding of vectors. One of the reasons why people like energy problems is energy is a scalar, and you don't have to do any of this stuff anymore. Okay. Any questions on that? I know it's my soapbox. I'm often on them early in the morning. You probably don't want to listen to it, but it is an important thing. 3 things today. We're going to do some polling, just only 4 questions this time. I'm going to work a problem, an inclined plane problem, because that was our first example of a good trigonometry problem. You can't get the problem right if you can't do trigonometry. Okay. Well, maybe you can memorize an equation, but you won't fully understand it. And then we're going to go off something I tried in my modern physics class on Friday. It worked fairly well. Of course, they're a smaller class. We're going to go out into breakout rooms. I'm going to create 6 of them. I have 6 problems. Each of the groups is going to work one problem, and then we'll come back and each one we'll go through them one at a time with a spokesman from that group kind of guiding us through. I did get a new toy over the weekend. I bought Notability. It's kind of a nice little app that I can write on. I'll be sharing it with you. I think if you're working a problem during class, a product like Notability works well. I'll provide some whiteboard space in Zoom for you to write with your mouse. But if that doesn't work, well, Notability or something like that might be something you consider. One of my students recommended it to me, and it worked fairly well. All right, so let's move on to the first thing, which is the polling. Let's see. So I need to share a screen with you. Let's share PowerPoint. Oh, it's on the wrong one though. So before I share it, let me cue up the right screen. All right, and share it. And then let's start up the poll here and launch the poll. And hopefully you're seeing a couple of vectors, P and Q. And the first question is, what is the sum of P and Q? Which was very similar to, I think, the hardest of the problems in the reading quiz yesterday, or this morning, whenever you chose to do it. I do see people get up early and do work, which is great. I appreciate your youth. And remember, we're doing the head to tail method here, right? All right, 16 people are in, 19, 20. All right, kind of thinking it out. I need to draw it myself. You'll see once I end the poll, that'll be the first thing I do. I'll tell you right now, just looking at the poll results here, the 2 top answers are A and D, which confuses me to some degree, but 26, and I think 27. All right. Been over a minute. I'm going to end it. All right, great. Share the results with you. And you can see, as I said, the big answers are A and D. And you'll notice that A came out red. And here's what you want to do. And let me get my pen tool here. And I'll do it in red. Remember, what we said about a vector like Q here is you can put its origin anywhere you want. What defines a vector is its magnitude, how long it is, and what direction it's pointing. The vector in and of itself is not defined by its starting location. So what I could do is I can take this vector Q and slide it any place I want. And what we say we should do is slide it to the head of vector P, the one we're adding it to, right? So we start with P, we slide Q right over there, and it's a vector. And then we said the resulting vector is the one that starts where P starts and goes to where P ends. And you can see that one most looks like A. So that's the sum of P plus Q. Vector addition graphically. Now, this is a great tool just for visualizing an answer. One of the things that I mentioned when we talk about problem solving technique is at the end of a problem, when you get an answer, look at it and say, does it make sense? One of the ways you know if your answer makes sense is if vectors were added, for example, you do some picture like this and you go, well, yeah, my answer could possibly, the numbers that I got could possibly be vector A. You know, you try to draw things reasonably to scale. You go, okay, that's reasonable. It's in the right quadrant is often a question. You know, this would be a number in the third quadrant, a vector in the third quadrant. And so both the components should be negative. All those sorts of things you know about algebra should turn out to be true in a calculation. Unless a calculus teacher or an advanced algebra teacher or somebody along in your educational mathematics background taught you something about the law of cosines or the law of sines, handling a triangle like this that doesn't have a right angle is a difficult thing. And so from a calculational point of view, it's a little harder to use, but from a visualization point of view, it's kind of essential. All right. And so I'll move my poll out of the way. It is A is the answer. And you can see the exact work that I just did a second ago is justifying it right there. All right, move on to the next one here. And now stop sharing this and share this. Start the next poll. What's the difference between the two? What is P minus Q here? Okay, and remember, we really only define addition. If we want to do subtraction, we add on a negative Q in this case. People are seeing it. I can just tell you the majority are getting the right answer here. So maybe the first one was just a warm-up issue. $22 in already. The majority are correct. $24 in. Majority are still correct. Good job. All right, just a couple more people. 25 are in. All right, I'm gonna cut it off here in about 3 seconds. There we go. I think everybody's in now. I'll end the poll and I'll share it with you. And you can see the majority of people are saying D, which I recognize was the majority wrong answer, I guess, in the first problem. My advice to you as we're going through these is have a little scratch piece of paper, okay? And the first thing I guess I gotta come up with is what's minus Q look like? And that would just be a vector in the opposite direction, because we said multiplying by -1 does nothing to the magnitude, it just reverses the length. And then just add on minus Q here to P. So I slide it over because the origin of a vector doesn't really mean anything in its definition, okay? And so I put the tail of Q, tail of minus Q, onto the head of P, and the resulting vector is the one that starts where P starts and goes to where Q goes, minus Q goes. And so that looks most closely like D. Okay, so that's the correct answer there. And a better drawing, if you don't like my kind of red sketch right there, saying that yes, the answer is D. Let's move on to the next one. I'm not showing answers here, am I? Good. All right, and this one's a little more complicated. And I'll launch it, because now it's asking for both multiplication by a scalar and then subtraction. So that's complicated. And just get yourself a little set of vectors, a little set of arrows on your paper. "18 people have voted and doing well, so good job. The majority of people who voted are picking the correct answer. And that's good. Good to see a steady improvement on this. The light bulb might be coming on for a couple people. All right, we're going to go just a little over a minute here. I'm going to cut it off in about 10 seconds. All right, I'll share the results with you. The overwhelming majority picked the correct answer. Let me not try to sketch out a picture. It's a little hard, but see, we've doubled A, right? That's what multiplying by 2 means. The vector preserves direction, stays in the exact same direction. So 2A right here is in the same direction as A was, but it's twice the length. And then, of course, we had to subtract off B. There's minus B. We did the head to tail method. We put the tail of vector minus B onto the head of the vector 2A, and there is how you do the mathematical operation of 2A minus B, the red vector, which most of you picked as A. Great job. Last one here. And let's launch the poll here. And the only thing I'd tell you, there are two answers I could probably live with. But if you remember right, we talked about coordinate systems that were rotated. Okay, it's very smart move to think about a coordinate system like that. And so give me the best answer. And remember, it's asking for acceleration here. Okay, give me the best answer given that coordinate system. All right, just about got everybody. So I'm going to end the poll here and I'll share the results. And we're kind of split. All right, a number of people picked A. A is an answer, it's just not the acceleration. Hopefully you realize if I just change that to the velocity, that's what's going on here. You'll give it some initial velocity right here, which is right there on my graph. The ball should roll up the inclined plane. At some point, it's going to stop right there. At some point in time, it'll stop right there. And then you'll expect it to roll back down. And so the velocity then is negative while it's rolling back down. And interpreting these graphs is an important thing, I believe. I would point out that that particular velocity versus time curve represents constant acceleration. I was grading, I've got most of the labs graded, a few more to do. And then, of course, some of you have Professor Kem, and he has to grade your lab. But when we were plotting the Bugatti and the Porsche, I guess, you were seeing a velocity versus time curve. And I'll graph the Porsche because this is more what the Porsche looked like. The Bugatti had an initial acceleration and the guy shifted into the next gear, slowed down a little bit. So he actually had two accelerations. But this was one of the velocity versus time curve. Notice it's not exactly a straight line. There is a acceleration here which is different from the acceleration there. The slope of the velocity versus time curve gives you acceleration in the exact same way that the slope of the position versus time curve gives you velocity. And so I kind of saw some distinct accelerations, one at the start and one at the end. And you might even have labeled the one in the middle. I would not have necessarily called it a constant acceleration, and yet a lot of people did. If part A, choice A here, was made into a velocity time curve, you can see it's perfectly straight. The velocity is decreasing linearly in this case. And remember, the slope of the velocity versus time curve is the acceleration, okay? And that brings us to the correct answer, which in my mind is D, okay? It's the correct answer. D is always a constant as seen here. And so the 7 of you that got that, great job. A big misconception people have is that when the ball gets up here, that its acceleration somehow goes to 0 for just a moment there. No, the velocity goes to 0 right there. The acceleration is simply the slope of this curve, which is D. And so that's the best answer for this question, okay? And so there's the answer. And acceleration doesn't change. Choice B here that the majority of you had, as we'll see next chapter in chapter 4, what this would imply is that somehow it's like that upside down house that's down in Orlando, Florida. Somehow gravity gets flipped on you and the acceleration due to gravity somehow becomes positive, and that just isn't physical. I could live with choice C because I decided to draw the coordinate system this way. Okay, so the one person who picked choice C, as long as you recognize that the acceleration is constant, I'm okay. This, by the way, would be a coordinate system drawn that way, where positive X was down the inclined plane. And there's actually nothing wrong with that. It's just not conventional. Okay, so I could live with either choice C or D, but the best answer here for the coordinate system I said to use is D. Any questions on that? All right, then I'm going to stop sharing this with you. Okay, and we're going to shift over. I'm going to do a problem. The problem I'm going to do, I guess, is this one, I think. Yeah, okay, I'm going to be doing this problem right here. Skier starts down an 11-degree inclined plane. Initial velocity is 5 meters per second. Final speed at the bottom is 16 meters per second. We can ignore friction. And I want to know what's her acceleration, what's the length of the incline, and how long does it take the skier to reach the bottom of the slope. You don't have to memorize that because I'm going to stop sharing this with you, and then I'll share with you my my iPhone, which has my new toy. Screen mirroring, good. See in Zoom. All right, put that away. And I don't necessarily like the way that looks. Can somebody, did that take? Why am I not seeing any of the participants? In the chat, would somebody just tell me if they're seeing my screen here? Yes, all right, good. Thank you, Nina, appreciate it. All right, so there's the problem restated on the worksheet. And hopefully, let's see if that will auto-rotate some. Okay, the first thing you always want to do when you have a problem like this is draw the picture, okay? And I put at the top of this, this worksheet page here, I've put what I think are the 3 equations you use to solve this guy, okay? And here's my picture. Yeah, let me rearrange my stuff here. Rearrange my stuff. All right. So there's my inclined plane for the skier. All right, and this is the 11-degree angle that's referenced. And if there's ever a confusion about where that is, just let me know. Okay, we know what the velocity is of the skier. There's my skier, they're boxes. Skier's a box. And I just gave a little space between the skier and the incline just because there's no friction. Sometimes when I draw the box right on the incline plane, that means we're gonna have to deal with friction, something we'll talk about in the next couple weeks, okay? I wanna draw the acceleration due to gravity here, okay, because that is what's causing the skier to go down the inclined plane. And of course, what we need to do is get the 2 components of the acceleration due to gravity, most importantly, the x component, all right? And I think the only other things on this diagram are what the initial speed is and what the final speed is, all right? Well, here's the problem, of course. I've got an 11-degree angle on the incline, okay? And I've got this G vector right here. I know the length of it, and I know it's oriented downward, okay? So G is 9.8 meters per second squared. And I got to get its 2 components, which is the subject of today, okay? This is the X component that I'm interested in. This is the Y component that I don't really care about, but it's there. And so what I'm going to do is I'm going to bring that X component down and make a right triangle. The 2 components always form a 90-degree angle, okay? And so all I did was slide the X component of the acceleration. I slid it so that it's on the head of the Y component, and I created a right triangle. The only thing that's necessary then is to figure out where's that 11 degrees, because you know it's not the 90-degree angle, it's one of the other 2, and of course, it's that one. And if you don't see that one, that's one to make an appointment for office hours or stay around after class and I'll show it to you. There's a number of ways to get there. The best practical advice I can give you came from an instructor I had in graduate school of all places. He said, don't draw your 11-degree angle like it's a 45-degree angle, because then you're confused. Is it this angle down here where I'm trying to draw a dot? Is it the one down at the bottom, or is it the one up at the top? And the answer is it's the one up at the top. Okay, so I'll get rid of that. And once you accept that it's the one up at the top, the x component of acceleration is opposite the 11-degree angle, and so it must be g times the sine of theta. All right. And that's the first step of the problem. You got to figure out what the acceleration is in order to use any of the three equations that are at the top of the sheet here. And so I'm going to say that's 9.8 meters per second squared times the sine of 11 degrees. And that should give me, I went to my calculator, 1.87 meters per second squared. Okay, and I look at the problem statement here, and I'm really only working with 2 digits. I am going to carry it out to a 3rd digit, just so I don't have some round off issues moving forward. Okay, everybody good with that? All right, now I need to move this somehow, and that could be a trick here. All right, it's not letting me show the rest of my screen. Let's go down here. There, okay, so I can move on again. All right, so I should write down the piece of information. We just decided that the acceleration in the y direct, or in the x direction down the inclined plane, is 1.87 meters per second squared. Okay, and so now that we've got that, let's answer the first question. What's our acceleration down or I'm sorry, with the second question, I just answered the first question. What's the length of the incline? And I look at those, this is the wrong problem, isn't it? And I'm not going to like this new thing as much as I thought I did. All right, so let's get rid of all that. Is there a quicker erase button? New toys, they always take a while to learn. All right, seems like that's gone. All right, there's my picture, and we got that acceleration. Let's figure out what the distance down the inclined plane is. And the equation I'm going to use, I think, that gets me there the quickest is this one. Okay, and so we'll start with it. Velocity squared is equal to initial velocity squared. We know both of those, plus 2 times the acceleration. We just found that out. I erased it, of course. 1.87 meters per second squared. And so the only thing I don't know is the distance down the inclined plane, okay? That distance that used to be right here between the 2 boxes. So let's solve for it. A little bit of algebra, manipulating around. I bring the initial velocity over to the other side of the equation. So I got velocity squared minus the initial velocity squared divided by twice the acceleration, right? Did that in 1 step. If you need to do it in 2 steps, maybe even 3, go right ahead, okay? And then I plug in all the numbers, 16 meters per second, and that's squared, minus 5 meters per second, and that's squared, and I'm dividing by twice that acceleration I just found, 1.87 meters per second squared. And when I take 16 squared, what's that, 256, right? Minus 5 squared, 25. And then I divide it by twice my acceleration. The number I got was 61.8 meters, okay? And let's see if meters are the right answer. In the numerator, I got a meter squared per second squared for both those terms, and I'm dividing it by a meter per second squared. So the second squareds cancel, and I've got a meter squared divided by a meter. Sure enough, it is meters, and so I would call that 62 meters. Okay, and so there's that's delta x right there, and so we've got the first 2 answers figured out here. And then the last one was, how long does it take the skier to get to the bottom? And so because I'm not being given the room I was hoping I would get from Notability here, let's erase that guy. All right, gone. And now, what equation am I going to use this time? Well, I went with this one just because it looks simpler, but truthfully, I could have used the one in the middle as well. Okay, and so now I know the initial speed, I know the final speed, I know the acceleration. Well, the only thing I don't know is the time interval, and that's what part C is asking me to find. And so I'll take the velocity final, and I drop the final subscript, you can put it in if you want, is equal to the initial velocity plus the acceleration times the time interval, okay? And so that means the velocity final minus the initial velocity divided by the acceleration is the time interval. And so if I plug in those numbers, I get 16, not squared this time, just 16 meters per second minus the 5 meters per second. And I divide that by the acceleration, 1.87 meters per second squared. And meter cancels meter. And this time seconds, 1/2. So I got 1/2 in the denominator, which means it's in the numerator. And when I did that math on my calculator, I got 5.88 seconds. And so now it's time to look at significant figures. I called this 5.9 seconds. I called this 62 meters. And I called the acceleration 1.9 meters per second squared. Okay, any questions on that? I'll stop sharing this with you. Once I make it go away, make that go away for now. All right, stop sharing, and I'll work on notability. And so the next thing I want to do is I'm going to pull up the worksheet for today and share that with you. Worksheet for today. Come on. Come on. There it is, and I'll share that with you. And where's Word? Where is Word? There it is. Share. Okay, and you can see, hopefully, there's the problem I just did. And there are 6 vector problems, which is why I'm going to divide us up into groups, into 6 groups, probably about 5 people. Some groups only have 4. And I'm hoping that I'll be able to see this in just a second. Okay. Create breakout rooms. Here's how, and it does this automatically. Here's the group 1, and that's Lou, Kristen, which is Quillen, right? Emma McTurk, Jackie Cruz, and Stephanie Provine. You're in group 1, and so you'll be doing problem 1 here, okay? The second breakout room is Andrea, Kyle, Maddie Summers, Michael Roseman, and Nina. You'll be doing problem 2 here, okay? And in the third breakout room, doing problem 3, is Allison Buckwalter, Cora Berry, Eberici. I'm not going to try your last name, Eberici. I got your first name. I'll work on your last name. Olivia Payne and Sydney Alexander. And you're doing problem 3. Group 4, I admit, group 4, 5, and 6, you kind of got just slightly harder problems. Group 4, that's Ellen Daly, Katie Eckhoff, Rachel DiMarcello, Shanice Frazier, and Tommy Hance. You're doing problem 4 there. And problem 5, 5 is Aiden Radinsky, Elena Hilario, Sean Curry, and I'm going to go with Yiha Wang. Am I saying that right? Shoot me a note and check on how you want that pronounced, if you would. You're doing problem 5, the 4 of you. And then the last group is everybody whose name I haven't called, which is Anna Gantz, Bridget Cartman, Jahil F., and Megan McHenry. You're doing problem 6 here. Okay, so I'm going to open up the rooms. It takes just a second for Zoom to put you. You should find yourself in a small group of 4 or 5 people and work on your particular problems. All right, go ahead. I'm able to jump in and out of your groups. Isn't that fun? All right, so one of the things you want to do is pick a spokesman, because your spokesman is going to have to declare what your group's answers are for problem 1. Okay, any questions on problem 1? All right, hopefully you realize the x component, horizontal component, is 2.3, the hypotenuse is 3.2, right? Meters per second in both cases. Figure out an answer, compare between the 5 of you, and pick a spokesman to tell us what your answer is. I'm leaving.
So 55 degrees below the X would be
Find the X and Y.
it's like is it more than halfway? Yeah, so it's like in between, more than halfway around the bottom, but not to the point where you'd be at 180. Because we gotta draw that out, and for the X and Y components.
Everybody okay in this group? I'm able to jump in and out, understand what you're doing. Maybe everybody's working the problem independently right now, and you're going to compare answers at the end. How's that sound?
Yeah.
All right, cool. You understand your problem? Your problem looks like it's in the 3rd quadrant, doesn't it? 240 degrees puts it squarely in the 3rd quadrant. All right. Any questions? So both your answers should be negative numbers, right? That's my one hint for your group. I'm leaving.
Thank you.
All right, it's awful quiet in this group. Any questions on your problem? You guys are group 4, if I remember right. Most of you are muted. Wow.
I don't have any.
You're good, you go? All right.
What's the best way to set up this problem?
What I would do is I would draw a picture first, okay?
Yeah.
And, you just kind of estimate, let's see, A is 3 and then -2, so 3 over, 2 down. And then, let's see, B is down 1, left 4, and then you can do the head to tail method.
Okay.
But then the next thing, though, is what do you do with the X components to add them? Well, you take the 3 and the -1 and you add them up, right? And what do you do with the Y components? Well, you add those. So you add the -2 and the -4, right?
Yeah.
And that should look like the resulting vector. I think that turns out to be in the 4th quadrant then, right?
Okay, that's what I was getting.
Yeah, and then, okay, and then so all you need to do then, once you've got the X and the Y components, is use Pythagoras' theorem to figure out the magnitude, and use the arctangent or any trig function to find the angle.
Okay, awesome. Thank you.
All right. All right, you guys that are muted, you guys are still helping Katie and I guess Ellen are the two that are talking here, right? All right, I'm jumping out though. I'll give you a couple more minutes to work. All right, everybody's muted in this room, which means you're not talking to each other, which is kind of the point. Any questions? I'm able to jump in and out of rooms, as you can see. Everybody understand that where the two vectors are? All right. Leaving the room. You guys got problem 5.
I'm not 100% sure about this part.
Hey, I'm able to jump in and out on you guys. I'll be honest with you, you probably have the hardest of the problem, and somebody left on you. There were 4 people originally in this group. What part didn't you get, whoever asked that question?
Part B, we figured out part A, and now we're trying to figure out the X and Y components on vector C.
Okay. So remember, what do you do with that? So
we know
tell me what your X and Y components were for A.
For A, they both were 28.3 meters.
Perfect. Okay. How about the 2 components for B?
21.2 meters.
Be careful though, because B is in the 4th quadrant. So I agree with 21.2. The X component is positive though, right? The Y component is negative. It puts you in the 4th quadrant.
Okay.
Got that idea? Okay, so now what do you do with those? Well, remember what we said graphically is you add the 2 X components.
Mm-hmm.
So that would be 28.3 plus 21.2, right?
Yeah.
And you add the 2 Y components, 28.3, and then I think we decided, hopefully I convinced you, that the Y component of B is minus 21.2, and you add those 2 up as well, and that should give you the components of the vector C.
Okay.
All right. Now, one thing about this problem we didn't ask you is to go to a magnitude and direction for C. That's a logical next step, but that would have made this problem very hard. Well, okay. So as soon as you've got the 2 components for A and the 2 components for B, add the X's, add the Y, and those are your components for C, right? And you're done.
Oh, okay.
All right.
Thank you.
You bet. I'm leaving.
So, Megan and Bridget, did you guys get the...
All right. Looks like I got people coming back from their groups, so I'm going to close all the rooms.
I have a question.
Okay, go ahead.
Just a simple question. So, since we all did one of these in our groups, what is due before next class?
One from the other page. So
Okay.
if you did either 1, 2, or 3, okay, then you have to do one from the next page, which is one from 4, 5, and 6. And we got a couple minutes here. We're going to go over it. All right. So group 1, which is Jenny, Kristen, Emma, Jackie, and Stephanie. What do you think? What's the angle?
I
you
think
have to find. Yeah, you did. You had to find the angle.
yeah. So for the question 1, the cosine of this angle should be 2.3 over 3.2, and the angle is 44, I think, by using a calculator.
Exactly right. Yeah. So here's the picture. If I turn my key on, what he was saying is there's the picture, and you're told that this is 2.3 and this is 3.2, and you're trying to get that angle. And so you took the inverse cosine of 2.3 over 3.2, and you got theta was 44. Perfect. All right. And you needed the y velocity then. So what was Vy?
I use the square of 3.2 minus the square of 2.3, and the square root of this answer is the velocity of the vertical velocity.
And what'd you get? What number?
It's about 2.2.
Yeah, 2.2, right? And you know it has to be close to 2.3 because this is close to 45, right? So
Yeah.
this kind of makes sense. And that's how you check your answer. But I agree, 2.2 meters per second. All right, perfect. How are we doing on time? We got just a couple more minutes. I don't know, we'll get through them all, but let's move up to the next problem. Hopefully, it's not letting me scroll. All right, well, group 2, which is, I guess, Andrea Kyle, Maddie Summers, and Michael Roseman. Why am I not able to see the entire? There it is. Haha. I just have to push the right buttons. All right, so here's your picture, I guess. And I think I jumped in, you were talking about this. There's your 55-degree angle, right? There's X and there's Y. And we got an answer for what your 2 components are? Nobody's going to talk, huh?
We got for X, it was, I might have these swapped, but it's for X 91 and for Y 131.
Okay. I agree with that. But I got 91.8 when I did it. And I'm calling it V for vector here. And that was, I made it, I guess I made it meters, right? So I called it 92. And for Y, they said minus 130. 131, yeah. And remember, they're both negative, right? Because you're in the 4th quadrant. So both your components are negative. That looks good. All right, now that I've figured this out, haha, there's problem 3, okay? And if you're not seeing my notability here, let me know. That's Allison, Cora, Abarici, Olivia, and Sydney. All right, so their picture is slightly different. All right, their picture was, come on, pen, work. There we go. Pen. Their vector was in that direction. They were given 240 degrees clockwise. Well, there's 180, right? And so 240 would be another 60 degrees right there. That's what I used. All right, you needed to get the X and Y components as well. So what do you have?
We got negative 4.76 for the Y.
I agree with that.
Then we got negative 2.74 for the X.
Minus 2.74. I rounded to 2.75, but close enough. Okay. And let's see, make sure I said the right thing here. Let me scroll up. What did I say here? Because, yeah, I said something wrong here. What did I say wrong? On problem 2, what's wrong? There's a point to be had here.
It's not negative in the X direction.
Absolutely. Who is that? Who's that?
Allison.
Allison, you get a point because I made a mistake. That's a positive right there, isn't it? All right. That one right there. Get rid of that. Okay, so now let's move on to the next number 4 here. And group 4 is, and we'll get through these real quick. Ellen, Katie, Rachel, Shanice, and Tommy. Get a magnitude with your components.
Okay, for CX, I got 2.
Okay, see what she did here? She took the 3 and the -1 and added them, right? All right, what's CY?
And then CY, I got -6.
Perfect, okay. And then we're running out of time here, so you just use Pythagoras' theorem to get the magnitude, and I got 6.32, and for the angle, I got theta is equal to -71.6. And so the reason for that, if that's not going to work, is the angle is down there, and so I specified that angle right there. That's why I got -71.6 degrees. All right, real quick on to the next group, which is, let's see, 5, that's Aiden, Elena, and Sean, and Yeehaw. What'd you guys get? Give me your final answers for CX and CY.
For CX, we got 2.6 meters, and then for CY, we got 4.5.
Excellent. That's exactly what I got. Okay. And what they did, hopefully, is you realize that vector right there, it doesn't have an X component. It only has a Y. You got to get the X and the Y components of the other, add the X's, add the Y's. And lastly, group 6, hopefully you didn't have to leave. Let's, I know I'm about 3 minutes over here. Go ahead. What'd you get for your final answers? I think we talked.
For the X component of A, we got 28.3.
Right.
And then for Y, we got the same thing.
Right, because it's a 45-degree angle. Perfect.
Yeah. And then for B, we got 21.2. And then for the Y component, it would be negative because it's in the 4th quadrant.
Right.
And then for C, the X is 49.5, and then Y is 7.1.
Yeah, and I rounded it to 50 and 7.1. But yeah, 49.5 and 70.1, or 7.1, I'm sorry. And now let's see, which quadrant? They're both positive, so it's in the 1st quadrant, so we're good to go. All right, hey, that's all I got today. 4 minutes over, sorry about that. Probably too much time in the talking at the beginning of class, but important stuff. We'll be talking about projectile motion on Wednesday, and we'll be doing a lab this week where you drop a ball, and that should be fun stuff. So we'll see you all later. Have a great day.
Thank you.
Bye.
Take care now.
Stay on here.
Yeah, if you want to stay around, I'll stay open for about a half hour, 40. It'll time me out at about 40 minutes if nobody has any questions.
Okay. I just have a question. It's not really about problems.
Yeah, it looks like, okay, there you are. Let me make, you're on my 31-inch screen right now. So there you go. What can I do for you today?
So I have to go to like a last minute trip to Florida. My brother's graduating from Naval A School.
Okay.
Yeah.
What's his rate?
He's an E3. He just.
Okay. Gotcha. So he hasn't. Okay, got it. All right. So
yeah.
Sounds good.
But his graduation is on Thursday.
Okay.
And I have lab on Thursday,
right.
So I wanted to talk to you and see what I could do for that.
Truthfully, the lab, I'm only there to answer questions. If you can, and you can ask questions by email if you got any. So you can do this week's lab without actually coming to class. If you can't be present physically on Thursday, all you got to do is get it done by Friday sometime. Okay.
Okay.
Yeah. So it can be done asynchronously. You can do it on your own. The one thing I guess I would ask you, do you have some kind of video camera?
Yeah, I do.
So you got your cell phone or whatever, you can make a recording. And can you transfer that to your computer? What kind of computer do you have?
I have a PC.
Yeah, I love the Macs for this. This is the one thing where the Macs are worth the money. Do you have a cloud?
Yeah, I have like a Dropbox and a cloud and all.
Okay, so you can put the video on your camera into that place and then access that with your computer and then download it. Is that you got that capability?
Okay.
Yeah, as long as you know how to do that. I'm not a big cloud user, but I use the AirDrop. I do have a Dropbox, as long as you can access that from your cell phone. But I think however you do this, so you get the video over there, and you have Logger Pro loaded.
I do.
Okay, and so the handout gives you directions on how to. You're importing the video into Logger Pro, and I think the command is insert, insert, and then you pull down the video, and you'll see your video you just shot with your camera will show up, and then there's some instructions on how to point to points on the video as it moves frame by frame through, and it creates graphs for you. It's kind of cool, I think, but you can do that on your own. My advice: when are you actually traveling?
I leave tomorrow at like 7.
Okay, so what I would recommend, if just to make sure that you know how to do it, just try it to see, are there any issues. Dr. Tech did it with his class last week, and the only issue was that transferring your video file into your PC.
Okay.
Some people had trouble with that. And when are you going to come back?
I come back Saturday.
Okay. Do you need more time for the lab then? Would you like? I mean, I picked Friday just so I could grade it over the weekend. But if you
I could have some more time, that would be
till Sunday, Monday.
Okay.
Is how Sunday ended, like end of the day Sunday work, like midnight on Sunday.
That
I don't want it hanging around on Monday though, because but yeah, I'll extend it. And I'm just, I'm not going to change it in Canvas. I'll just say, hey, since you're traveling, it's a good thing to do. Congratulate your brother. What's he? So he's an E3. Is he going to go to a surface ship? Is he going to go to a submarine? Where's he going to go?
I don't know.
Okay.
I don't think he really knows either. He found out.
Is he in Jacksonville right now? Maybe
he's in Pensacola.
Pensacola. So he's probably going to be an aviation guy then. Yeah. Some kind of, he'll go to an aviation. What's that?
I said he found out like last Thursday he was graduating, and we bought our ticket like Saturday.
Okay. Pensacola's a neat town. Haven't been there in years, but it should be fun and support your brother. Yeah, we'll give you more time. In terms of class, on Wednesday and Friday, just get the worksheet problems done. That's really you could do that. Will you be able to like log in on your phone or something? Or are you gonna?
I'm gonna try to. Like, I'm bringing all my stuff. And so I'm going to try my best to, but Thursday was like the biggest day.
Yeah. Okay.
Do anything.
As long as you do the lab yourself, and we'll give you more time since you'll be out of town for an important event. Not a problem. All right.
Okay. Thank you so much.
Sunday and today. And if there's something that goes on with your travel that you can't get that done, just let me know. But try to make get it done Sunday afternoon.
Okay. And I'm going to try to do the lab, like the video drop, all that, the Dropbox, either today or Tuesday. So if I have questions, you should
because otherwise I do have a backup plan for you if you can't make that work, but try to make it happen so that you can record the video. It literally, the videos I recorded 30 seconds maybe, and most of the time is me starting the camera, then I walk over so I'm in the frame and I drop the ball. One thing you do need is you need a ruler or a yardstick or something, right? You
if it's just like, I have like a clear ruler.
Yeah, you know what you might try. So what I did is, I see you got a door in the back. Stand right in front of the door with like a dark ball, and all you have to know is measure with a measuring tape what the height of your door is. That's all you need. And so the directions tell you, okay, go from the top of your door to your bottom of the door. You make a line, and then a screen will pop up and tell it what the height of your door is in meters. Okay.
Okay.
So I look at the door in your background right there. That's what I did. I actually taped a meter stick onto my door, but I realized I just could have measured the height of my door, and that could have been my reference scale to tell You have to tell Logger Pro so it could convert pixels to distance. So you have to have an object of a known length completely in the frame. And so when you set up your camera, make sure you can see top to bottom of your door, or one of the panes on your door would work too. As long as you know the distance, the height of one of those things, that should be a good scale for you. All right.
Okay. So as long as I measure from top to bottom.
Right. Top to bottom, as long as you can see all of that in your frame when you take your video, you should be good to go.
Okay. Perfect. Right. Thank you so much.
You bet. Have a good day.
Thanks. You too. Bye.